I trained a machine learning model and got almost 100% accuracy, which sounds amazing. But there are two possibilities here. Either I built an incredible model, or my model is cheating. And in machine learning, this happens more often than people think. Hi, welcome back to my channel, and if you're new here, my name is Anna, and on this channel I explore machine learning concepts in a simple and intuitive way. Let's get started. Data leakage happens when information enters the training process that wouldn't be available in the real world. So your model looks great during validation, but only because the experiment is contaminated. It's like giving a student an exam but accidentally printing the answers on the back of the page. The student gets 100%, but that doesn't mean that they understood the material. Normally, the model should learn only from the training data. Then we test it on data it hasn't seen before. But with leakage, information from the answer, the future or the validation set sneaks into the training process. So the score looks impressive, but the experiment is no longer honest. Now let's make this concrete. Here we have a simple synthetic financial dataset, and the goal is to predict one thing. Will the market go up tomorrow? That means at prediction time, we know today and the past, but we don't know tomorrow. So the rule is simple. The feature is valid only if it exists before the prediction. First, we create the data and build honest features. Past returns, moving averages, volatility, and volume changes. These are allowed because they only use information from the past. Now I intentionally add one bad feature. Leaky tomorrow return. This is basically tomorrow's return, the thing we are trying to predict. So if the model uses this, it's not learning the market, it's reading the answer key. Now we train the model twice. First with only honest features, the score is realistic. Then with the leaky feature included, the score suddenly becomes almost perfect. And this is the whole point. The model didn't become smarter, it saw tomorrow. This is why data leakage is so dangerous. It doesn't make your model look broken. It makes your model look amazing. Then we look at a more subtle example. A centered moving average. It looks like normal feature engineering, but it can use future prices inside today's feature. That is also leakage. So for time-based data, the safe pattern is train on the past, test on the future. And before trusting any score, ask, would this feature actually exist when I make the prediction? If the answer is no, your model might be cheating. This example was obvious because we named the column Leaky Tomorrow Return, but in real projects, leakage is usually more subtle. A validation score doesn't automatically tell you whether your model is good. It tells you how well the model performed inside the validation setup you created. If that setup contains future information, duplicate rows, target-like features, or pre-processing fitted on the full dataset, the score is not measuring real performance. It's measuring how much information leaked. Data leakage turns validation into an open book exam. Here are some common ways leakage happens. Suppose you are predicting whether a customer will churn, but one feature is account close date. That is not a feature, that is a spoiler. This is very common in time series problems. For example, predicting tomorrow's stock movement using a feature calculated from next week's price, the model appears to predict the future, but actually the future was used to create the feature. Another subtle case is pre-processing before the train test split. For example, this looks harmless, but the scholar has already seen the full dataset, including the validation data. The safer pattern is to split first, then feed pre-processing only on the training set. Leakage can also happen through duplicates. If the same patient, customer, image, or document appears in both training and validation, the model may not be generalizing. It may just be recognizing something it has already seen. This is not prediction. This is déjà vu. And finally, random splits can be dangerous when the data has time. Imagine training on data from December and validating on data from March of the same year. That is backwards. In production, we don't get to train on the future. Before trusting a score, ask, would this feature exist at prediction time? Did I split before pre-processing? Did I feed scalars and encoders only on the training data? Are duplicates or related samples crossing the split? For time data, did I validate on the future? Is the score suspiciously good? The most important question is not, does this feature improve the score? The most important question is, would I actually have this information when making the prediction? Data leakage is dangerous because it gives you confidence at exactly the wrong moment. The notebook looks clean, the metric looks impressive, the model looks production ready, but the real world doesn't include the answer key. So when your model performs unbelievably well, don't celebrate immediately. Investigate. Ask, did the model learn the pattern or did it accidentally see the answer? I also have videos on principal component analysis, linear regression, and RAG if you want to go deeper. If you found this helpful, feel free to like the video and leave a comment. It really helps more curious minds like yours discover the channel. And if you want more videos like this, consider subscribing so you don't miss future videos. As always, all the resources, including the code, will be in the description below. Thanks for watching and I will see you in the next one. Bye!